Hybrid energy conservation reduce energy needs. A practical using passive cooling of ammonium chloride. I am Kimaya Sharma, student of class 9K of DPS School, Bangalore East. I am deeply interested in energy conservation, real world pollution control, and sustainability projects to help the nation reduce its dependence on external countries. This project matters to me as India spends a lot of foreign currency on importing fuels. Then industries waste huge amounts of heat and then consume more energy for cooling. I want to show how chemistry can conserve energy in two directions, reducing the use of energy for cooling and also reusing heat. Aim. The industrial energy problem. The problem in industries today is that industries use a lot of energy and they waste a large amount of it. They waste around 20 to 50% of the energy that they consume. Massive losses occur via hot exhaust gases and hot cooling water, and the wasted heat disperses into the surroundings without doing any useful work. The aim of the project is to demonstrate a hybrid thermochemical energy conservation model that recovers lost heat for reuse and also reduces the energy used for cooling. This is experiment 2, solution of ammonium chloride, the reduction of cooling energy. The process here is that ammonium chloride is added to water and then stirred. It dissolves by absorbing heat from the water and its surroundings, which is an endothermic process, and the water temperature can drop by several degrees. The energy conservation role of this chemical here is that the cooling is achieved without running electrical cooling equipment, and ammonium chloride is not used for heat storage either. It reduces the electricity normally required for cooling, thereby conserving energy by lowering power consumption. Now we will conduct the experiment. Solution of ammonium chloride, reduction of cooling energy. The apparatus we have used here is a digital weighing scale, 20 gram of ammonium chloride, a thermometer of probe type, 100 gram water, and also a glass stirrer. This is distilled water and this is ammonium chloride. The process here is that ammonium chloride is added to water and then stirred. It dissolves by absorbing heat from the water and its surroundings, which is an endothermic process, and the water temperature may drop by several degrees. Energy conservation role here is that the cooling is achieved without running electrical cooling equipment, and ammonium chloride is not used for heat storage either. It reduces the electricity normally required for cooling, thereby conserving energy while lowering the power consumption. As you can see, the thermometer is already inside the ammonium chloride. Here is showing as 23.4 degrees Celsius. Now we will be adding the water and stirring. Just first add the water. As you can see, the temperature drop has already started. Here I have been stirring for the past 10 seconds and the reading is currently showing at 5 degrees Celsius. The entire ammonium chloride has not yet dissolved. It is almost dissolved though. Resolution of endothermic salts such as ammonium chloride in an aqueous solvent drives a significant cooling effect by absorbing around 6 to 8 kilojoules of heat energy. But 20 grams of ammonium chloride dissolved in 100 grams of water. This temperature reduction is achieved passively, requiring no electrical input. The thermal output is comparable to a 400 to 600 watt electrical cooling device operating for around 1 to 2 minutes approx. Industrial possibilities. When chemical reactors use ammonium chloride like systems, it can absorb excess heat and provide passive cooling packs in food storage and transport. In battery and fuel cell cooling, it can reduce the need for active chillers, as well as in pharma fermentation, it can provide cooling without dedicated chiller. Chemistry enables smart systems. Sodium acetate trihydrate stores heat and returns it when required, while ammonium chloride absorbs heat and acts as a cooler. Together, they form a hybrid mode of energy conservation, reuse of lost heat, as well as reduction of energy required for cooling. Therefore, this model can help industries conserve both fuel and electricity, improving overall sustainability. Thank you for your time and attention. I express my gratitude to Raman Award Foundation, my school Delhi Public School Bangalore East, my mentor teacher Miss Arul, and my parents for their support and encouragement. Thank you.